Okay, in this video I'm going to do another rationalizing the denominator example, but I think this one will be a little trickier and maybe a little non-standard, probably stuff that a lot of you won't encounter. So again, here are a few of the basic rules that I had in the previous example, so don't want to go through those all again. But suppose we have this problem here. Suppose we have x to the fifth over 6 plus the cube root of 7. Okay, what we're going to do in this problem is we're going to make use of the formula a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. So this is known as the sum of perfect cubes formula. And the idea is, if I can cube cube roots, I'll basically get rid of them. So what we're going to do is we're going to assume that we sort of have the number in front is going to be our a value, the cube root of 7, that's going to constitute our b value. And it says in order to make that into something cubed plus something cubed, what we have to do is we have to multiply by this stuff. Okay, so that's what I'm going to do. Okay, one thing I'm going to do as well is I'm going to rewrite the cube root of 7 as 7 to the 1/3 power. That'll be the first thing I do. Alright, so now I have to start multiplying. Okay, it says what goes on the bottom. Again, our a value is equal to 6. Our b value is going to be the 7 to the 1/3 power. Okay, it says we multiply by a plus b, so that's going to be 6, or excuse me, we've got a plus b, we're going to multiply by a squared, which is going to be 6 squared, minus a, which is 6, times b, which is 7 to the 1/3 power, and then it says we add to that b squared, which is going to be 7 to the 1/3 power, all squared. Okay, so if we multiply it to the bottom of our fraction, we're going to have to do it to the top as well. So 6 squared minus 6 times 7 to the 1/3 plus 7 to the 1/3 squared. Okay, and let's see what happens here now when we start foiling all this out. When we distribute the bottom, the idea is, again, I'm multiplying a plus b times its a squared minus ab plus b squared formula. It says we should get 6 cubed plus 7 to the 1/3 cubed, which will be 6 cubed plus 7. So let's see if that happens or not. Okay, on the top there's really not a lot to do. Okay, so I'm just going to rewrite the numerator. Actually, I'm going to give myself as much room as I can here. So it says you get x to the fifth. 6 squared is 36, minus 6 times, 6 times the cube root of 7, plus this is going to be 7 to the 2/3 power, which equivalently I could write as the cube root of 7 squared, or 49 if I wanted to. Okay, and now my big denominator, so I'm going to foil everything out and be pretty careful here. So it says you get 6 times 6, which is 6 cubed. If I take 6 times the negative 6 times 7 to the 1/3, I'll get minus 6 times 6, which is 36. Then I'll get my 7 to the 1/3 power. If I take the 6 times the 7 to the 2/3 power, well, I'll get plus 6 times 7 to the 2/3 power. Plus, on the inside, I'm going to get 6 squared, which is 36, times 7 to the 1/3. Okay, if I multiply the 7 to the 1/3 by the middle term, I'm going to get negative, what do I get? Negative 6 times 7, and if I multiply 7 to the 1/3 times 7 to the 1/3, I add the exponents and get 7 to the 2/3. And then again, I'll take 7 to the 1/3 times my last term, which is 7 to the 2/3. That'll give me 7 to the 3/3 if I add the exponents, or equivalently just 7 to the 1st. and that should be a plus in there. I don't think I did anything. Let me make sure one more time. Yeah, I just should have made that a plus. Alright, so let's see what happens. So our numerator is left alone. So we have x to the 5th times 36 minus 6 times the cube root of 7 plus the cube root of 49. Kind of tedious stuff here. And let's cancel things out in the denominator, and this is where things should hopefully all cancel out. So it says you have negative 36 times 7 to the 1/3. Hey, I've got a positive 36 7 to the 1/3. So those cancel out, which is good. And notice as well, I've got a positive 6 times 7 to the 2/3, and negative 6 times 7 to the 2/3. Those cancel out. And the only thing that I'm left with is the numerator. The only thing that I'll be left with is the 6 cubed plus 7. Well, 6 cubed, I'm pretty sure you can check, this should be 216. So really all I'm left with is 216 plus 7, which will give me 223. Okay, and that is now my solution. The denominator is now rationalized. Okay. Alright, I hope this example helps out a little bit. If not, feel free to send me an email, and I'll try to make it clear. Alright, good luck.